Well, hello there. It's been a while since I've recorded a video here in my computer room, but we have a little project coming up that's a little different than what we've done in the past, and so I figured that this was a good format to use. I mentioned a couple of videos ago that Mike had procured a Fathom playfield and backglass, and that he intended to try and build a table from that. He doesn't have any of the rest of the electronics, and he doesn't have the donor box or the uh, back glass area or anything. He just has the glass and the playfield. And so he's been trying to gather up all of the parts necessary to build this table. He's found some of them, but he hasn't found all of them. And one of the things that he has not been able to find is a 3 drop target inline drop target. He can find some 4 side-by-side drop targets, but he can't find any inline drop targets. And so we have decided that we're going to build our own. Well, not completely. We're going to take a donor 4 side-by-side target and convert it into a 3 inline target. Actually, 2 of them. And so this video is going to show you that project kind of from start to finish to see what it takes and whether we can do this and whether 3D printed material is strong enough to hold up to the forces of one of these drop targets in actual use. I'll show you what we are kind of thinking about doing, and then along the way I'll show you us actually doing that and then testing it out and seeing how well it works. So here you can see up at the very top of this thing 3 blue inline drop targets. And these are fairly unique drop targets. Now, when the game first starts, the computer lowers these drop targets. So it has solenoids in here that can knock these targets down. And when these targets are down, you can shoot a ball up into this trough and get it stuck in this hole here. And this is part of the multi-ball game feature. So once a ball drops in this hole, the targets are reset up, and then you have to knock them back down. And once you've knocked all 3 of them down, then it ejects the ball, or somewhere along the lines. I'm not exactly sure about the complete gameplay of this thing, but somewhere along the line it'll eject this ball out. And then you have a couple of balls on the playfield. And there's another one of these over on the right. You can't see it in this picture, but in this picture over here on the right, there's 3 green inline drop targets. Same sort of arrangement. There's a saucer back in the back that'll capture a ball. And then when you reset it, once you get the ball in, it will reset. And then you have to knock the things down to free the ball and start a multi-ball play. So we cannot find, or Micah has looked all over the place and could not find any of those types of targets. But what he was able to find was a 4 target side-by-side unit that came from a Miss Pac-Man game that has plungers that will reset it. Now, while a lot of the hardware is the same, there are some definite differences between the inline and the side-by-side targets. And what we're going to try to do is take the components from the inline target and 3D print everything else we need, or manufacture out of metal or something, all of the parts we need to convert the inline, or convert the side-by-side targets into inline targets. So that's our project. So let me bring you down to the table here and show you the target that we are starting with. Okay, what you are seeing here is a standard 4-drop target inline drop target unit. I said inline, I didn't mean that. Side by side, a 4-drop target side by side unit. And down here on the side is the reset solenoid that'll reset all of the ones up. And then these little solenoids, by the way, I have one of these out that I was taking measurements with for modeling. But these solenoids will fire forward and hit the individual targets. And it's hard for me to get my fingers in here, and drop them down. And then the reset solenoid will reset them. The typical drop target unit, and these are used, boy, in almost every pinball machine out there that's been made in the last 20 years. Some variant of this. Some have 3, 4, 5, 6. I think there might even be a 7-unit one. Most of them don't have this feature, though. But then on the newer machines, there's quite a few. Like 8-Ball Deluxe has, I think, a 6 or 7 DELU. Yeah, six drop target unit that has plungers like this that will let the computer reset the target to where the player was on the previous ball. So anyway, what we need to do is take this unit and rotate these 90 degrees and spread them out 1.5 inches and get rid of one and only put 3 of them in there. So I have been doing some modeling that will allow me to accomplish that. Now, what we're planning to keep out of this unit are the side plates. We'll get new plungers. We're going to use 3 of these solenoids, and we're going to use a reset solenoid and the reset hardware down here, but we're going to 3D print and remanufacture pretty much everything else that's in here. The top plate, the plate that holds the solenoids that reset it, the bottom plate, those are all going to be 3D printed, and the back plate is going to be 3D printed. So let me take you back to the computer and show you some of the CAD design work I have done up until this point, so you can see what our design looks like. So I've designed this hardware that we're going to 3D print in FreeCAD. I used to use Fusion 360, but they've changed their license policy, and I'm going to have to pay for it now, and I'm not going to pay as much as Autodesk wants for Fusion 360, so I decided that I would learn FreeCAD. And while it's a little harder to use and not quite as intuitive as Fusion is, it is completely capable of doing everything I need to do. So to start off with, let me bring up the drop target assembly that I started modeling, and this, if you guys want to know about using FreeCAD and stuff, I can do some separate tutorials on that. But there's these drop targets here. Pick your workbenches, and you can bounce back and forth between different workbenches to do whatever work you need to do. So when I design a part like a drop target or this plate, I do that in part design, which is a classic design capability that lets you draw. It lets you create a sketch, and on that sketch you can draw circles and squares and polygons and stuff, and then you can extrude those to make solids, cut holes in them. They call them pockets to make mounting holes or accessways or whatever, a typical CAD capability. And they have several tools to let you assemble things. A2 Assembly Tube Plus is one of the latest that works with their current release of software, which is version 18. With version 19, they're coming out with a new alignment assembly tool called A4 or Assembly 4 or something like that. I haven't played with it yet. But anyway, I started out by just measuring and modeling up the existing unit, and I got about this far, and I said, okay, that's enough of that, because we're really only going to use the side plates and the drop targets. Everything else is going to have to be replaced. So I'm going to take you right to the current finished design, which is this one right here. So I have one drop target showing. You can see that these are rotated around. The only reason this is red is because there was a problem with it that I had to fix. And I was sharing it with Mike, so I made it red so he could see the problem. So you can see that while this is the same metal plate as we had before, this back plate is a lot thicker. It's 5 millimeters thick, and it's cut with some slots to let the drop target be mounted sideways. Now in FreeCAD, you can hide things just by hitting the space bar. So let me hit the space bar on a couple of these, and let me show you what we've done here. The first thing I had to do is figure out how to make the solenoid move the drop target sideways instead of straight back. In the original design, the plunger comes out and it just hits the face of the drop target, pushes it back, and it acts just like the ball does. But when you turn it sideways, obviously that plunger is not going to work. So I figured that the simplest thing to do, this part of the plunger is plastic, would be to mill it down to a cone shape so that the cone could come out and slide it. Now, I've never seen what one of these looks like in real life. I don't know how Bally designed their unit that knocks it over sideways. And if anybody has pictures of that or something, I would love to see it, because I can't find any online so far. One of the issues I had when I was designing this was that when the target is raised, this plunger would have to hit on this face to knock it down. And that would work fine. It would push it over, the thing would drop, the plunger would retract, and this would drop down. But if for some reason this plunger fired again, like the switch didn't register that it had gone down or something, and this target, it fired again, it would smack right into the back side. It would smack right in here somewhere, and that could be a pretty hard smack, and there's nowhere for this thing to go. It can't move in that axis. So I figured that could cause some damage. And the only way I could think to get around that would be to glue a little piece of plastic onto this body that's level with the face of this, and then move the plungers over, well, to the right in this picture, so that even if this plunger was down, the point would still miss that face. So that's the design we've come up with. The other thing we needed to do or we're going to need to do, is manufacture our own angle bracket. Now, I have seen the angle brackets that Bally uses, and they look just like this, except we can't find any of those either just by themselves. But we figured we can get some half-inch angle iron, cut it to length, drill a hole through it, drill a hole in the back. And this is a nut that bolts onto that, and just a screw on the inside. And then there will be a nut out here. This will actually probably be shorter, just about the length of that. And then a nut will capture that on there. So this piece needs to be able to swivel like this, and then the plunger needs to be able to swivel back and forth. So that accomplishes that. So I have colored all of the parts that I'm going to need to 3D print in light blue, so it's easy to see what I'm going to need to do. And I've actually already started the 3D print running. I could get the bottom, the back plate, and the top plate on the printer's print bed at one time. I was not able to get this shelf for the solenoids on there, but it's actually not ready to print yet anyway, because it's not in here, but there's a little 90-degree bracket back here with some holes in it that I need to model up and punch those holes in before I print this. That's just a couple of minutes worth of work, so I'll get that done in a little bit. This is a 9-hour print job right now, so I got plenty of time to get this done. But it'll get it printed, and then I'll be able to assemble this and see how well it works. Well, it's really hard to see the black on black plate, but you can see here in the front is the top plate, the bottom plate, and that's the back plate back there. It's still on its initial laydown of the first layer, so it's running really, really slow as it does that, but it starts speeding up once it gets onto the second layer. So anyway, we have 7 hours and 45 minutes left to go. Well, my 3D print has finished. There is the back plate, the bottom plate, and the top plate. And over on the 3D printer, the solenoid plate is printing out. So when that is done, I will start the assembly process. My 3D printing has finished, and this is the result. I've screwed it together. I've got all 4 pieces printed out, the bottom, back, top, and the solenoid shelf that's going to go in here. Now, there are a lot of little issues with this, and it is by no means ready for prime time. First of all of my screw holes are too tight. When I screw these screws in, I get a little cracking. Some of these were so small that I had to use different screws to screw it in, and so I haven't forced a lot of screws in here. I just put in enough to hold it together. So that's the first thing that's wrong. The next thing that's wrong is on the solenoid shelf, and this actually has quite a bit of modification to do. First of all, I forgot the holes that go behind the solenoids for the rubber bumper that stops the solenoid from hitting. However, if you notice, this bracket isn't screwed down. And the reason that bracket isn't screwed down is because the holes don't line up. I need to move these holes about 2 millimeters. I haven't measured it yet because the battery in my measuring tool has died on me. But the most severe problem with this is that I got the hole spacing wrong for this. Let me go around to this side. So this, and this is, let me tilt it around this way so we get everything lined up right. So this hole and this hole connect to that hole and that hole. But this is much shorter than that. And the reason it's much shorter than that is because when I modeled up the holes in this plate, I put this hole in the wrong place. I think I put it at this offset as opposed to the correct offset. And then I modeled the plate to fit, I modeled the shelf to fit the plate. And so I need to fix that. So that's something that will need to be fixed in the next version. The back hole seems to be in the correct position, so I can mount it with one screw in the back hole and tilt this down. But this whole shelf is a little too short. So I'm going to need to fix all of that, basically. And another thing that I'm going to need to fix, and this is just because parts change as you design. Let me grab this. This is the old style carrier for the drop targets. And when I modeled this design, I was using this box, and so I used this plate. However, the drop targets in the newer ones use this kind of design. And the reason for that is it makes it easier to ride up on the switch that mounts on the back and push it out of the way. I think that little round thing would catch and hang sometimes and not work. So this was obviously a modification they made to make the switch work easier. And that's all fine and good, except for on my design here, once this is in here, that keeps this from lifting all the way up. So I'm going to have to extend these slots up basically the distance of that so that those will fit in there. So far, that's all I found that's wrong. Other than that, the fit looks really good, works really good. And on black, it's really hard to see in there, but all the holes line up. The drop targets fit in just fine. Let me see if I can find the one I have loose. So the drop target, well, there's some way to get it in here. I've had it in here before. I guess it goes in from the back. There you go. So the drop target will sit in there. It will catch on this, and when it drops, it'll drop down as it's supposed to. That's about as far as it drops down because there's a 3/4 inch plywood table top here. So this only lifts out that far and then drops back down that far. You can see all of that. I'm sorry you're getting kind of swamped out. It's really, really difficult with the jet black and the light hands. Makes it really difficult to see. But anyway, that's it. So far it's coming along really good. These holes you can see in the back here are for mounting the switches, and they are aligned to these slots right here. So the switch will hang down here and this metal thing will lift up. One of the things I'm not sure about, and I'm going to test that before I leave here, is, let me pull the old back plate off. So these switches are designed to mount on the back plate and have the correct clearance so that when that thing slides up, it makes. This is only 1.6 millimeters. My plate is 5 millimeters, so I'll probably have to take a couple of the spacers off of here to get that to align right. But I think it should. But I'll check that all out in this fit section before I modify my models and send it to the printer for a second go. So that's it. It's looking pretty good. So I'll bring you back after I get the drop target in here, and maybe I'll see if I can get one of these modified with the point on it like I want to, so that we can figure out if that's going to work or not. So that's it. Thank you. Okay, I'm going to hand hold this since this is going to be just a quick little short video. But down in there you can see, if it would focus, okay, darkness. You can see the little manufactured piece there. And if I grab the reset solenoid and click it up, it latches in. But you can see the angle that this is sitting at. It's not straight because the slot needs to move back a little bit. If you, pop it like you pop it with a ball, it drops down. So that all looks good. And I'm pretty sure that's less than 3/4 of an inch. So it's down below the tabletop, which should be fine. So other than getting things straightened out, I think this is a fairly good design. So the new back plate is printing, and with it, the slots in the back are taller, so it should fit this. And I've made the new back plate a little thinner, well, about half as thick as it used to be, just to give more clearance for the switches that are going to get mounted back there. So once that gets printed and I reprint my new swivel, we'll take another look at it and see what it looks like, and then maybe I'll redesign. In order to straighten this up and move the slots, all I should have to reprint is the top plate, because I want these parts to stay exactly where they are. But that'll probably also change the solenoid plate that has to mount in here. We'll bring you back when we get the new designs done. Okay, here is the finished working prototype. I've gone through about 3 revisions of every piece that's on here. These are still had some hand modifications done to them though, so I still need to print out the final revision of this, and when I do that, I'm going to print it out in solid material. But basically, this is the design. I got a couple pieces of white cardboard up here to hopefully make it easier to see this, but I'm not sure it does. Anyway, the reset solenoid here will reset all of the units. Let me pull back a little farther so we can see all of this. There you go. My screen's showing on the sides because my cardboard isn't quite wide enough. But anyway, there you go. So that was the reset. And then the plungers can pop in here. Whoops. You got to hit it. You got to smack it in fast to spring it over. But anyway, there you go. That's how it works. It looks like it's going to work fine. My plan now is to build up a little test rig that can energize these solenoids, and I'll reset it, I'll drop them back down, and repeat that a few thousand times to see how well everything holds up. I do want to show you the little ramp section that I created, but to do that, I'm going to show it to you on the screen capture in digital form. It's so small and so hard to see on camera that I think the digital rendition of it will be easier to see. Okay, so what you're seeing here is a little clip-on piece of plastic I just 3D printed. It's just flexible enough to slide over the shaft and snap on the back. This unit isn't, or the drop target here isn't drawn quite to scale, but there's like actually a ramp that comes down to this little spring clip here. So I had to cut a little notch in the bottom of this for that to clear. and it just clips on and holds all by itself. Now we'll probably glue the final one on, but it's working really well so far. Just snap them on there and they seem to hold and stay. Now how long will they last to the impact? I don't know. We will see that with the testing. So that's gonna finish this little video on building a 3 inline drop target, or modifying a 4 side-by-side drop target into a 3 inline drop target. At some point in the future, it's going to be probably a few weeks, we'll go ahead and print the final plastics, and we'll build up 2 of these for use, and see how that works. I do have testing I want to do where I repeatedly reset and drop these targets a few thousand times. So I need to build myself up a little solenoid driver test rig and set it up for this thing and get that going. So once I have that working, I will go ahead and run the final test on this. And once I'm satisfied that this will make it through a few hundred games without failing, we'll go ahead and print up the final design of whatever we have come up with, and with any fixes we find along the way, and that will go into the Fathom table that we are building. So thanks for watching, guys.